Hey everyone, I wanted to make this supplemental video on the vector product or cross product because we really don't have time to cover what I'll do in here during lecture, but it's still rather important for torque especially, which we'll cover in chapter 10. So, to start off real quick, vector product is basically multiplying two vectors and getting a third vector out. So what do I mean? Well, let's say up here in the corner, because I need to reserve room, if we have some general vector A multiplied by vector B, those two are perpendicular to each other. When you cross them, and that's important, when you cross them, you get a third vector, which we'll call A cross B, that's perpendicular to both A and B. Okay, and that's important. The cross product is always perpendicular or orthogonal to its constituent vectors, A and B in this case. Okay, so very generally, at face value, we need to take cross product. You can, there it is. You can take the magnitude of the cross product to be such. The magnitude of A times the magnitude of B times sine of the angle in between vectors A and B. Okay? So this is something you'll just have to take at face value. It's the magnitude of both vectors times the sine of the angle in between. Okay? We'll use this coming up. It'll be important. Okay? That's the magnitude of this cross product of this new vector. Okay? So, how do we get the actual vector components? Well, we have to follow rather strict protocols, right? You'll see a bunch of terms coming up, but if we walk through it term by term, we shouldn't have too much of a problem, okay? So to cross two vectors, what we are essentially doing is, hypothetically, if we have vector A with components in I hat, J hat, and K hat, and we're crossing, not necessarily multiplying, but crossing with vector B that also hypothetically has vectors in the X, or components in the X, Y, and Z. See? Okay. Okay. So, here we go. You ready? Let's go. The first term is, you'll take the first term of A and cross it with the first term of B. And what do I mean by that is that you'll take the magnitudes, AX, BX, but then you'll also need to take along their unit vectors. So in both of those terms, it's I hat, and because we're crossing, it's crossed with I hat. All right? So that's the first term. Then, to keep track of things, let's do AX crossed with, so this one crossed with the second term of B. I'll tell you what, let's do, I don't like, oh crap, that's so big. I don't like parentheses around the magnitudes. Okay, now let's do AX times BY. Now, keeping track of their unit vectors, we have I hat cross J hat. And the third term associated with AX is AX cross BZ. So thus we have the I hat unit vector from AX crossed with the K hat unit vector from BZ. Okay. And this is 1/3 of the way through this entire expression here. Okay? Eventually we'll have 9 terms. So, on to the 4th term. Now we're doing AY with the first term in B. So thus we have AY times BX times, let's see, that is J hat cross I hat. 5th term, AY with BY. And that is J hat cross J hat. And then AY with BZ. Okay, 2/3 done. Now last term, AZ with BX. Notice I'm keeping the order of these unit vectors exactly the same as they are taken from the above expression. Okay? Notice they're not necessarily in alphabetical order. We'll worry about that shortly. So now we have AZ with, what am I doing? Let's see, go back. We need AZ with BY. This one. AZBY. Almost done. K cross J. And then the 9th and final term, AZ with BZ. Okay. If this looks like one mell of a hess, believe me, it is. Okay, it's okay. But let's reduce this down to make a little more sense of it. Okay, so keeping in mind that the magnitude of the cross product, which is what we're ultimately doing, is the magnitudes of A and B and sine of the angle in between. Now, remember that if we draw a little unit vector coordinate axis, let's see, we can have, which way do we want? We want this I, J, K. Now, I've drawn this incorrectly. Let's see. Sorry, scratch that. We want to make this coordinate axis what's called a right-handed coordinate system. So we want to use your right hand, your index finger, your middle finger, and your thumb. If you stick all 3 of those fingers out such that they are all 3 perpendicular to each other, that is a right-handed coordinate system. So if your pointer finger is the I hat direction, your middle finger is J, and your thumb is K, orient your hand right now, pause if you need to, and orient your hand such that it lines up with this coordinate axis down here. And so I will try and assign that and do the same thing here. Let's see. I will do I hat on this one, J hat up there, and K hat down there. 1, 2, 3. Okay, so K hat effectively is coming out of the page. Okay. This is important. This right-handed coordinate system is how we will determine how to reduce these 9 terms in this ugly freaking expression. Okay? So, keep the next table in mind. So, a brief aside. Let me put note here. We'll come back to those terms. If we were to hypothetically cross I with itself, what is this? Well, the magnitude of both, which is 1 times 1, the angle in between I hat and I hat, well, they're the same vector, thus the angle is 0 because they're effectively parallel, thus the sine of the angle 0 is 0. Okay. cross product of parallel vectors is 0. So now, let's see what happens when we cross I with j. Well, again, if you take your right hand, in the order left to right, your pointer finger's I, middle finger's j, thus your thumb pops out and will be plus k. I hat cross k hat now. What's I hat cross k hat? Oh no. Down here, we have I hat, j hat, and k hat. If we go this way, I cross j in that order is plus k. Okay. If, for example, we have I and then we go around this way to k and then that way to j, it's actually a negative. Okay? So now, on the next line, we can have j cross I. This is going in that same backwards direction, right? Reverse alphabetical, if you will. So going from j over to I gives us a negative k. Now we have j cross j. Well, again here, the angle in between parallel vectors is 0, so thus this term is 0. And then j cross k. Now we're going in correct alphabetical order. So now the answer here, we have j, and then k, and now going around to plus I. Let's see, last row, k hat cross I hat. This is, again, reverse alphabetical. So from k to I gives us, oh, I'm sorry, it's not. It's actually quote-unquote alphabetical. We're just following that same alphabetical direction in this circle. So k to I gives us plus j. Sorry about that. Then we have k cross j. Now we're going backwards. So this is negative I. And lastly, k cross k, again, 0. Okay, so keep this in mind when now we can use that to evaluate some terms up here and simplify those. Okay, so every term that has identical unit vectors crossing each other is 0. So that goes away, that goes away, and that goes away. And so now we're left with the following, right? We have, let's see if I can do colors. Let's see, let's do red. Let's do red. So now we have an IJ term here. We need another IJ. We have that here. Let's do green now. Can't really see that. We have an IK term. Let's do this IK. And then lastly, we have a third. Let's do blue. JK, JK, so to speak. Okay. Now, let's combine those terms, right? So let's rewrite. Let's go new slide. We have AXBY. Whoops. AXBY and then AYBX, J cross I. Back to this term. We have AYBZ, J cross K. And what was the other blue one? AZBY, K cross J. And then let's do the greens now. We have AXBZ and IK. And then we should have AZBX, K cross I. AZBX. Nice. Okay, we've rewritten it. Now, right here, the ones that are in reverse alphabetical order, this guy right there, that's equal to what? J cross I, right there. J cross I is minus K. So thus, this is equal to K as well. So now I'm going to rewrite those two terms into one term, like so. And I'm going to do the same thing for J and K. JK is I. KJ is minus I. Let's combine those. AYBZ minus AZBY. And that is, factoring out the I hat, we have that. And then plus the third term, I cross K. Oh, what's that? Minus J. K cross I. That's plus J. I'm going to actually write it like this. AZBX minus AXBZ. Factoring out J hat. Okay. All right. So now we have a final vector. And again, this is the cross product vector. If you remember from long ago, these have three components to them, right? These are just magnitudes in the parentheses, but they each have an I hat, J hat, and K hat component, right? So we can actually end up rewriting that like such. Because by convention, cross products are written with this little quirk in there. There's a minus for the J hat term. So we have AX, BC. To put the minus out front, I need to take out a minus. Thus, what am I doing? AZBX. And then the K hat term, AX, BY. Whew. Okay. Holy cow. Now, this is the cross product. It's ugly, it's messy, it's not the most fun unless you like math and pain and misery and torture, but this is the cross product. Okay? So, let's do an example. Let's do an example where, how do you copy things? Let's try this. Copy. Oh, yes. Look at that. All right. Oh, crap. What happened to it? Well, didn't work out quite as well as I hoped. Let's do an example. Let me rewrite this really quick. Phooey. You know what? Let's just use an example crossing A with B such that A has values of, let's say, 1, 2, 3, and B has examples of 2, 3, and 4. Okay. So, what we had was AYBZ minus AZBY. Again, these are the magnitudes of each of these components. AYBZ minus AZBY. So AYBZ means we have, let's do it like this, 2 times, so AX, AY, AZ, BX, BY, BZ. AY, BZ. 2 times 4 minus AZBY. 3 times 3. This was the I hat component. Then we subtract, what was that one? J hat was AX, BZ. So AX is 1 times 4 minus AZ BX, yep. AZ was 3 times 2, and this was J hat. And then we're finally adding the K hat component, which was AXBY, which was 1 times 3 minus AXBY, AY, BX, 2. There we go. Okay. Okay. Just make sure AXBY, AY, BX. AY, BX. Okay, cool. So now we just evaluate. So this is 8 minus 9 I hat subtracting 4 minus 6 J hat plus 3 minus 4 K hat. So this is negative I hat minus a negative 2, which is plus 2 J hat, plus, nope, just kidding, negative K hat. All right. So this is our new vector. Through all that rigmarole, okay? There's an easier way. There's an easier way. Let me show you that right now, after I've taken 20 minutes of your life, okay? So, AX, or A times B, A cross B rather, we can write it like such. This is a weird way, but it's a very efficient way. It's a shorthand. So if you have components, whether or not you actually have non-zero numbers, right? You can do these if you just have an I and a J component, thus the Z or K hat would be 0. But this is called a determinant. This is a determinant, and it's a shorthand way to do all of that crap that we just did. Okay? So, let me show you how to evaluate it. We want to ultimately get, or I allege, will get the same thing that I've boxed above. Okay? So, when evaluating the I hat term, we want to effectively cross out temporarily the column and rows that intersect at that unit vector. So actually, let me just do that and that. And now we have this grid here, this AY, AZ, BY, BZ, this 2 by 2. And so now how we evaluate this is we take upper left to lower right, we multiply, and then subtract lower left times upper right. Which looks like this. AY times BZ, which was this, minus AZ times BY. Excuse me. And this is the I-hat component. So this pattern here, this pattern of upper left times lower right, subtracting lower left times upper right, that's a determinant pattern. And we repeat that for the other two terms. So now subtracting I just realized this will be a little bit complicated if I cross it out, but it's okay. I'll just need to rewrite them. BX. Okay. Now, for the J-hat, guess what? You cross out the row and the column that intersects at the J-hat vector in that 3 by 3 determinant matrix. Right? So before I write, I'll cross them out. So now we do that same pattern now. But now we have AX and BX, and then AZ, BZ over here. But guess what? We still do that same pattern. So this is AX times BZ, subtracting AZ, BX. You may have noticed that the subscripts, the components, they are flipped, right? They reverse. So that's the J-hat component. And for the K-hat, very similar thing. Except now we cross out first row, third column, such that we have this. So now it's AX times BY minus AY times BX. So this is actually the same as here. It's the same. AYBZ minus AZBY. It's the same exact thing. But this determinant right there, that's just a shorthand to do this 9-term mess. Okay? So I would suggest keeping that determinant in the back of your pocket. Right? So thus, the answer for this determinant is the same as what is boxed. Minus I hat plus 2J hat minus K. Okay? It's just a quicker way to do it. If you remember upper left to lower right, right? Subtracting lower left times upper right. Okay? That's the key here. All right, and with that, I think that's about it as far as this video goes. Thanks for watching. It turned out to be a little longer than I anticipated, but I hope you enjoyed it and you learned some stuff, okay? I will see everybody later.